Okay, so we are starting on Unit 6, which is our quadratics unit. We've actually already done a little bit of quadratics in fall semester, but now we're going full board and learn everything that we need to know. So let's talk about quadratics, what they are. So remember, they are a second degree polynomial, and in their standard form, they always look like y equals ax squared plus bx plus c, where a, b, and c are coefficients, or just plain old numbers. Okay, and they're in decreasing order by degree, so x to the second, this is x to the first. X to the 0 is the same thing as 1, because anything to the 0 power is 1. So this is really x to the 0. We just don't write it down like that. We have graphed quadratics before. We're going to start by graphing some again. So this should be a little bit of review. Sorry about the bell there. So let's start with the function 2x squared minus 4x plus 1. So the easiest thing to do is kind of take each function that we have and kind of break it down into its parts. A little bit easier for us. So our a value is going to be the number in front of the x squared. Our b value is going to be that center value, and our c value is going to be that last value. So our a value is 2. Remember, they're only numbers. They do not have any letters attached to them. B would be -4, and c is 1. Now, if we're going to go ahead and just graph first, we can certainly do that and plug in values here. And let's just see what happens. Maybe we'll get lucky with this one. So for each one of these values of x, we're going to plug them in for x into the function. And sometimes I like to do the work kind of to the side. So 2 times -2 squared is 4. -4 times -2 would be +8 plus 1. So that gets a value of 17. 2 times -1 squared is 1. -4 times -1 is 4 plus 1, so that gives us a value of 7. 0 is easy to plug in because we've got 0 minus 0 plus 1, so that's just going to be a 1. So that's pretty easy. 2 times 1 squared is 1, minus 4 plus 1. So 2 minus 4 is -2, plus 1 is -1. So let's keep going here. 2 times 2 squared is 4, minus 4 times 2 is 8, plus 1. Okay, and then 2 times 3 squared is 9, minus 4 times 3 is 12, plus 1. So that gives me 18 minus 12 is 6, plus 1 is 7. So remember, with parabolas, the interesting thing is that you need to have matching pairs of values. Okay, and we do have matching pairs there. So let's graph these out. So we've got, I'm going to start with that one. -1, 7, 0, 1, 1, -1, 2, 1, and 3, 7. This -2, 17 is fine. It would be way up here somewhere, so I'm just going to leave it out for now. So on this one, we kind of got lucky because we actually found the vertex. Remember, the vertex is the point at which our parabola changes directions. Okay, so at this point, this is our vertex. So our vertex is at 1, -1, which was our center point right here. And our axis of symmetry is the x value of that vertex. So if we could take our imaginary line, remember, an axis of symmetry is just exactly what it says. If you cut that parabola right in half, you would have half on the left and half on the right. So in that case, we got kind of lucky, but it's actually easier and more accurate to start with your axis of symmetry and your vertex, because then you know exactly what points you need to pick. So let's try that. Let's try the same idea with another equation. How about -4x squared plus 4x plus 8? And I want you to go ahead and write down the a, b, and c values and then check them against mine. Go do that now. So for your a value, you should have gotten -4. B value should have gotten 4. And c value should have gotten 8. So for our axis of symmetry, remember that we have a formula for that, and that is -b over 2a. So it helps that we have our a, b, c values. So we're going to take the opposite of our b value, which will give us negative 4, and 2 times our a value, which is negative 4. So we would get negative 4 over negative 8, which gives us 1/2. So the nice thing about this is that axis of symmetry, not only is it the midpoint of our vertex, of our parabola, right there, but it also tells me the x-coordinate of our vertex. So if I needed to find the vertex now, I could simply plug in 1/2 into our equation and it would give me an output for that point. So let's go ahead and do that. We have negative 4 times 1/2 squared plus 4 times 1/2 plus 8. And I know you see the fractions in there and you're going to get a little freaked out, but don't. So negative 4, well, 1/2 squared is 1/2 times 1/2, which is 1/4. So those 4s are going to cancel each other out. Half of 4 is 2 plus 8. So the 4s cancel out to 1s. Negative 1 times 1 is just negative 1. So we really have 10 minus 1, which is 9. So our vertex is going to be at 1/2 and 9. So before we finish graphing that, what direction do you think that parabola is going to go? Think it's going to be a right side up U or an upside down U? We've done a little practice with this. So this a value tells us what direction that parabola is going to go. If it's positive, like in the one before, it's going to be a right side up U. If it's negative, it's going to be an upside down parabola, which is exactly what we're going to have. Excuse me. So once you find the vertex, the other thing is now you know what points are going to be useful to you. If I, for example, plugged in the point 5 for an x value, that's great, but my point would be way down somewhere. It doesn't really help us a whole lot. So, like if you're going to borrow an eraser from somebody in your class, you're usually going to mooch that off the person sitting next to you. You're not really going to go all the way across the room to borrow that, typically, right? You're going to go right next door, right here. So I want to start with 0 and 1 because they're the next closest points to the left and right of my axis of symmetry. So I'm going to start with these two right here. Because the other thing is my vertex is right in between here at 1/2. And the other thing I like is that 0 is really easy to calculate. So 0 squared is 0 times negative 4 is just 0 plus 4 times 0 plus 8. So my zeros are gone. That's just going to give me an 8. Okay, let's try 1. So we get negative 4, 1 squared is 1, plus 4 times 1, plus 8. So the 4s are going to cancel out. 4 minus 4 just cancel out, and I just get 8. So now I've got 2 points. There's my matching pair, right? So I want you to kind of predict what do you think is going to happen now if I move out one more point in either direction. Do you think they're going to have similar points or different points? So let's try it. We have negative 4, negative 1 squared is 1, plus 4 times negative 1, plus 8. So I get negative 4, and negative 4 is negative 8, plus 8, which just gives me 0. Let's try it with the 2. 2 squared is 4. 4 times 2 is 8, plus 8. Well, negative 4 times 4 is negative 16. 8 and 8 is 16, so negative 16 plus 16 also gives me a value of 0. I'm not even going to graph that negative 2 right now, because I don't really need it. I have 5 points for my graph. I'm kind of good. So I have negative 1, 0, and 2, 0. So later in this unit, we're going to have a special name for these 2 points down here. So they can be called a variety of things. They're going to be called roots, solutions, zeros, and x-intercepts. They have 4 different names they can go by because that's the kind of information they give us. Okay. So later in this unit when you hear those, I want you to think of this picture right here. Okay, good. Let's go to the next page. Alright, so let's try 3x squared minus 2. Now some of you are looking at it going, wait a minute, Miss V, hang on. Last page we had y's going on. Oh, down there we had an f of x. Remember that y and f of x are interchangeable. They just represent output. So y and f of x just represent output. Represent the output. What comes out of our machine once we put a number in there. Okay, so they're the same thing. All right, so let's do the same thing again. So I have an x squared value. What is this missing? It's missing an x value. So let's rewrite that and see what we really have. We really have 3x squared plus 0x. I don't have a middle term. So there's still a number of x's. It just happens to be 0. There's none of them there. Minus 2. So our a value is 3. Our b value is 0. And our c value is negative 2. So let's find the axis of symmetry first, which is going to be easy because our b value is a 0. So we kind of like that. Negative b over 2a. Well, the opposite of 0 is just 0. And our a value is 3 times 2 is 6, but it's really irrelevant because 0 divided by anything is 0. So our vertex is going to be even easier to figure out because now we can plug in 0 into our equation. So 3 times 0 squared minus 2, which is just going to give us negative 2. So if this helps you at all, when you have no middle term like that, your vertex point is always going to be 0 and then whatever this number is here. So this, in this case, 0 and negative 2. So we can go ahead and graph that right there. That's our vertex is at 0, negative 2. Our axis of symmetry is at 0, so it's right down the y-axis. Okay. And now we can go one to either side. So here's where some people have a hard time figuring out what numbers to plug in. So here's my desk, and I need an eraser. And Bill's on this side of me and Susie's on this side of me. So I'm going to come over here and ask them for an eraser first before I go way over here and ask somebody for an eraser, right? This is the most convenient. It's right next to us. So those are the places I'm going to go. So I'm going to do negative 1 and 1 first. Then if they don't have something for me, then I'm going to go next over, negative 2 and 2. So you just kind of go to the left and right of your point each time, plugging in that x value to figure out a y value. Okay, so I'm going to do negative 1 first. So 3 times negative 1 squared is 1 minus 2. So 3 minus 2 equals 1. And we'll do 1. Well, 1 squared is also 1 minus 2 equals 1. So now I've got those matching pairs set. Negative 1 and 1 and 1 and 1. Let's go with negative 2. So 3, negative 2 squared is 4 minus 2. So that's 12 minus 2 is 10. And then 3, 2 squared is also 4 minus 2 would also give us 10. So remember, you're going to have pairs. You have the vertex is one standalone number because it's right in the middle. But then when you go out, you've got matching pairs that should be the same value on the way out because they are equidistant from that axis of symmetry. Okay, so let's go ahead and finish graphing that. So we have negative 2, 10, and 2, 10. And we know it's a right side up parabola because our a value is positive, and it's going to look just like that. Okay, good. That should have been a good review for you. We'll move on to 6-2.